Okay, so we're going to go over the Chapter 10 review. Okay, first question says, in an article in a local newspaper reported that dogs kept as pets tend to be overweight. Veterinarians say that a combination of both diet and exercise will help these chubby dogs get into shape. The veterinarians propose 2 different diets and 2 different exercise programs. Okay, so Diet A, owners control the portions of dog food and treats. Diet B, a mixture of fresh vegetables with the dog food, and substitute regular dog treats with baby carrots. Okay, then there are 2 exercise plans. Exercise plan 1, 3 30-minute walks a week. Exercise plan 2 is 20-minute walks daily. Okay, so it says 60 dog owners volunteer to take part in an experiment to help their chubby dogs lose weight. Okay, so part A says identify the following. The subjects. Okay, so the subjects, these are the chubby dogs, right? These are the ones we are experimenting on. Okay, the factors, okay, and the levels. Okay, so we've got 2 factors, okay, and 2 levels for each. Okay, so our factors, one factor is diet, okay, and within diet we have 2 different levels. We have level A and level B of the diet, right? So we got 2 levels there. The other factor that we can change it and look at is the exercise plan. Okay, and so we've also got 2 different levels of our exercise plan because we've got the 3 30-minute walks and we've got the 20-minute walks daily. So we have 2 factors, right? And they were diet and exercise, and within each of those we've got 2 levels. Okay, now that potentially gives us 4 treatments. Okay, so down here it says the number of treatments. Okay, and the way we're getting this is because we can do lots of different combinations, right? We could do, for example, Diet A with Exercise Plan 1. We could also do Diet A with Exercise Plan 2. We could do Diet B with Exercise Plan 1, and then we could also do Diet B with Exercise Plan 2, right? So those are all the options we have. So for treatments, so 4 different treatments. Okay. Now, I know sometimes in these experiments, they will say that some of the dogs were given like no treatment, where maybe they weren't walked or they weren't given a special food, but that's not specified in here. So we're assuming that all of these dogs were given either A or B and either plan 1 or 2. So that way we've got the 4 different treatments, okay? The response variable is what are they measuring in the end? So they're trying to see if these chubby dogs are going to lose weight. So the weight is going to be the response variable, okay? So for part B, it says design an experiment to determine whether diet and exercise programs are effective in helping dogs lose weight. Draw a diagram to represent your experiment. In your design, identify how randomization and blinding should be used. Okay, so I don't really quite have enough room to do this on the front, so I'm going to turn over to the back, and I'm just going to put this on the back side of the paper here. Okay, so I'm going to go ahead and draw my experiment. So I've got 60 chubby dogs. Okay, we're going to randomly assign their treatments. Okay, so we're going to have 4 different treatments. So we're going to have 4 different groups. Okay, so we've got group 1, group 2, group 3, group 4. Okay, we'll just say that group 1 is doing plan A with exercise plan 1. So this is diet an exercise, right? We can say group 2 is doing A with exercise plan 2. Group 3 is doing diet B with exercise 1. And the last group can do diet B with exercise plan 2. Okay, so those are my 4 different groups with 4 different treatments. Okay, at the end, I'm going to take the results from all of these and I'm going to compare weight loss of these dogs. Okay, so there's my diagram. All right, so it was asking me to go ahead and to explain what I'm doing and identify how randomization and blinding should be used. Okay, so for randomization, we want to randomly assign these 60 dogs. So splitting them into 4 groups equally, that would be 15 dogs per group. So we're going to randomly assign 15 dogs to each group. Okay. And within those groups, we have 4 different treatments. And so those treatments were, for example, I'll call this A1, A2, B1, and B2, right? Okay. At the conclusion, we're going to compare the weight loss of the dogs. Okay. Blinding in this situation will be difficult to do with the owners because the owners can visually see like what kind of dog treats they're feeding their dogs and how much they're feeding the dogs. So blind, and they're obviously going to be walking their dogs like a certain number of times a week. So we're not necessarily going to be able to achieve blinding with the owners. Okay. But to achieve some blinding, maybe the owner should not be told what the purpose of this experiment is. So we'll just say owners should not be told purpose of experiment. To achieve some blinding, right? Because if the owners know that the experiment is for like because they want to measure weight loss, then maybe the owners are subconsciously walking their dogs farther, or walking their dogs a little bit more than they're supposed to, or feeding them a little bit less treats, right? So we don't want to tell them, I guess, what the purpose of the experiment is. Okay. And when we're conducting the comparison of the weights, we're not going to tell the researchers which dog was in which group. Okay, so we're just going to let the researchers analyze the data, but we're not going to actually tell them like which dog was in which group because we don't want them to be biased in any way with their conclusions, okay? All right, so that is that problem, okay? All right, I'm going to flip back over to the front. Okay, so I'll just put C back page. Okay, So let's take a look at number 2. It says label each statement below, E for experiment, S for observational study. So part A, similar patients with heartburn are randomly given 2 different doses of a new drug or a placebo, and their heartburn symptoms are observed. Okay. So we're actually giving 2 different doses, which here these would be your 2 different treatments. Okay. And so because we're giving some type of treatment and then trying to measure the result, okay, and then their heartburn symptoms are observed. So we're looking at these results in the end. Okay. So we're looking at the effects. All right. This would be an experiment. Okay. All right. Let's look at part B. The weights of school athletes and non-athletes are compared. Okay, was there any treatment assigned? Like, are we feeding them? Are we having them do a lifting program to increase their weight? Are we doing anything like that? No. We're just strictly observing the weight of athletes versus non-athletes. So we're not forcing some kids to be athletes and some to be non-athletes, right? We're not prescribing a treatment. So this is a study. Okay, there's no treatment that's happening. Okay. All right, next one. Incidences of cancer in people who live near a chemical factory are compared to those who did not live near this factory. Okay. So I know some of you guys might be saying, oh, well, people who live near a chemical factory and didn't live, that could be like a treatment. Well, it's not a treatment. You're not forcing anyone to live in a particular place. You're just observing a situation that is actually taking place. Okay. So it's not like we're specifically taking people and locating them to a certain region of the world to live by a certain thing and then seeing what the effects are. We're just strictly observing this situation that's already taking place. So this is a study. Again, there's no treatments involved there. Okay. All right, let's look at number 3. Okay. Explain why placebos would be used in an experiment. Okay. Okay, placebos are probably the best way to create blinding in an experiment. Okay. All right, number 4, explain why blinding is important when conducting an experiment. Okay, so blinding is important so that none of the individuals involved in the experiment end up changing any of the outcomes. Okay. All right, let's look at number 5. Okay, number 5 says explain the differences between a study and an experiment, which can determine causation. Okay, so a study observes something that happens and no treatments are assigned in a study. That's the big difference. Okay, in an experiment, you're going to still observe what happens, but you're actually assigning treatments. Assigns treatments and determines effects. Of those treatments, right? So which can determine causation an experiment can determine causation? Okay. All right, so an experiment can determine causation, a study cannot. Okay, let's go to the back. Okay, explain the difference between a prospective study and a retrospective study. Okay, prospective is like looking forward. So this one here, we are looking forward. So generally, the group we want to study is identified. Okay. And then followed for a specific amount of time. Moving forward. Okay, so it's like, oh, we're going to identify 100 women between the ages of 35 and 45, and we're going to follow them for the next 5 years and look at how their diet affected their weight. Okay, that's a prospective study. Moving forward, we're identifying now and we're taking a look as we go at what's happening. Okay, retrospective. This is where we look back at the past at what has already happened. Okay, so say we're going to do a study of how online learning in the past 6 months has affected student grades. Okay, I'm going to look back at the last 6 months. Okay, I'm not looking forward to something that's going to happen. I'm looking back at what has already happened. Okay, all right, so last, number 7, a headline in local newspaper announced video game playing can lead to better spatial reasoning abilities. The article reported that a study found statistically significant differences between teens who played video games and teens who do not, with teens who play video games testing better in spatial reasoning. Is their claim based on a study or experiment? Do you think the headline was appropriate? Explain. Okay, so first of all, it doesn't mention anything about an experiment happening or any treatments being assigned. So this is definitely based on a study. And it actually reported that a study found, right? So it's based on a study. Okay. Their claim was that teens who play video games between and teens who do not, the teens that played games had better spatial reasoning. Okay. So it said video game playing can lead to better spatial reasoning abilities. Okay. Do we think the headline is appropriate? Okay. Well, first of all, we know that a study does not prove causation. So I don't believe that the headline is appropriate. Okay, I kind of think they're making a claim where there could be a lot of other variables involved. Okay. So there could be other variables or causes that lead to spatial reasoning. Okay, besides video game playing. Okay, so to just say that that's, the one thing that's going to make your spatial reasoning better, I don't know about that necessarily. So I don't necessarily know if I believe that headline is quite appropriate. Okay. I mean, we might see a correlation there, but it's definitely doesn't prove causation because it is coming from a study. It's not coming from an experiment. Okay.